रंग चढ़े खुद का ही खुद पे बच्चों को तू ऐसे बढ़ा बचपन मना रे यारा बचपन मना रोशन हो ये नन्हे दिए इन्हें तू रोज सजा बचपन मना रे यारा बचपन मना जादू है ये जीने दे जरा बचपन मना रे यारा बचपन मना गिरने दे बढ़ने दे उनको पास आए तो गले भी लगा बचपन मना रे यारा बचपन मना नई ये दुनिया नया आसमां बच्चों को बचपन से ही सिखा खेलते खेलते साथ निभा ऐसे तो उनका जीवन सजा ये बचपन है त्योहार हर दिन का ये पहचान ले और रोज मना बचपन मना रे यारा बचपन मना बचपन मना रे यारा बचपन मना बचपन मना रे यारा बचपन मना अरे अब तो मना ले यारा
Good evening, everyone. I'm Varun, and I work with the Bachpan Manao team at Eksa Foundation, and I'll be your host for this evening. Bachpan Manao is an initiative of Ekstep, a not-for-profit foundation co-founded by Nandan and Rohini Nilekani and Shankar Maruwada. At the heart of Ekstep is people-centric transformation at societal scale. Bachpan Manao is a 100+ organization mission to celebrate and recognize the abundance of childhood for the 0 to 8-year-olds in India. Today's Bachpan Manao Masterclass is called Brain Beats, How Rhythm Shapes Language and Literacy by Professor Usha Goswami. Usha Goswami is Professor of Cognitive Developmental Neuroscience at the University of Cambridge and a Fellow of St. John's College, Cambridge. She is also the founding director of the Center for Neuroscience in Education. After training as a primary school teacher, Usha decided to pursue research in child psychology. Her core interests are the neural mechanisms underpinning language acquisition, including relationships to the rhythmic structure of infant and child-directed speech, and the brain basis of dyslexia and speech and language difficulties. Currently, she is researching the potential utility of assistive listening technology and brain-computer interfaces to improve phonological learning by children, coupled with music and rhythm-based behavioral interventions. The masterclass will explore how early childhood experiences that involve speech rhythm, such as baby talk, shape a child's language development and learning to read. What are the benefits of using baby talk and singing to babies? How are children's speech sound awareness rooted in rhythmic learning? What is the link between speech rhythms and brain rhythms? These are questions that Professor Goswami will answer and explain through findings from the Cambridge Baby Rhythm Project, a cross-language research program. This masterclass brings attention to the early years and how, in these years, simple acts like singing, reading aloud to children, and body movement are a window of opportunity to boost brain and language development. It is a showcase of how there is an abundance of learning opportunities for our youngest children and a means to leverage them. Now, I would like to hand it over to Professor Usha Goswami to take you through this. Thank you.
So thank you very much, Varun. And thank you for inviting me to talk to you this evening for this very important initiative that you are doing in India. So I'm going to talk a little bit about the research we've been doing here in Cambridge over the past 30 years, trying to understand the links between rhythm and dyslexia, which led me to start looking at how the brain begins acquiring language in the first place. So I will share some slides with you now. Oops. Hold on. That's not at the beginning. One sec. What shall I do? Sorry about that. This is the first slide. So I'm going to talk about our research on rhythm and why talking and singing to babies is so important for their language development and then their literacy. So when you think about a child learning to read, it seems that the new skill is to do with the visual system. But actually, whichever language you're learning to read, you're interpreting speech when it's written down. And it's individual differences in speech processing that seem to explain why some children struggle to learn to read and others do not. And in fact, it's individual differences in having access to the sound structure of speech, the so-called phonological system, which seems to underlie these individual differences in children's reading success. So one of the core questions in my research program is to understand why these differences in the ability to think about phonology, about the sound structure of speech, why do they arise in the first place? So we need to think about the speech signal as an acoustic input to the brain. And in fact, when we talk, because we're using our muscles in our throat and in our mouth and our tongue, to move energy through the air, what we're doing is creating a rhythmic signal or quasi-rhythmic that has many different speeds of rhythm patterns in it, because your tongue might be moving faster than your jaw, for example. So you've got all these different rhythms in the energy being transmitted through the air, and then they reach your ear and are transmitted to your brain. And we know that infant brains begin tracking these different rhythmic energy waves or sound waves using brain signaling or cell networks of cells that also fire rhythmically, because they're either emitting a pulse of electricity or they're recovering from emitting that pulse. So the brain has all these different rhythmic speeds. There are these different speeds of rhythm energy in the speech signal, and the baby's brain gets going trying to track these individual rates of change. And in fact, what our research suggests is that differences between babies, which are quite unconscious in how well their brain can kind of lock on to these rhythms, is predictive of language outcomes. So the way we did that in our project was we had over 100 babies enrolled from 2 months of age, and they came in for brain imaging sessions during that first year of life, 8 times, so once a month almost. And there were 3 types of rhythmic input. There was a simple drum beat, which the baby would watch a ball dropping onto a drum, so it was something interesting to look at. There was a rhythmic speech sound, which was the lady shown here saying the syllable ta, 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 ta. So it was the same rhythm rate as the drum beat, but it was speech. And then there was singing. So there was this lady was singing nursery rhymes to the infants, like Twinkle, Twinkle, Little Star. And we were showing these videos to all the babies, so they all saw the same input, and we were recording their brain waves. And what we found was that the way that the brain locked onto these different rhythms was predictive of their language acquisition over the following years. So for example, both for the ta syllable and the drum beat, which the picture is just showing you brain waves aligning themselves in time with these different inputs, which we measured at 2, 4, 6, and 9 months, individual differences in how quickly the brain locked on to the beat were predictive of the later vocabulary of the children and also of their phonology, so their ability to hear these speech sound structures. And that was using electrophysiology. And we're also able to use those electrophysiological measurements of these different brain waves occurring beneath the scalp to reconstitute the speech signal. So this is showing you the nursery rhyme, the sort of averaged envelope or sound changes coming to the brain in orange, and then the brain's response from both an infant in our study and also from some adults that we tested with the same nursery rhymes, how well can we recreate that speech signal from the brain signal? And you can see that the accuracy is actually very similar for the infant and the adult. Again, there are individual differences, and the individual differences that we found by 11 months in how precisely the baby's brain was tracking the speech predicted their language outcomes when they were 2. So it makes one think about the importance of baby talk. So before I show you a video of our study, do you think baby talk helps learning or hinders learning? So as I mentioned, when we're talking, we are moving energy through the air by using the force of the muscles in our throats and our mouths and so on. And we also know that because the brain is either on or off, or an individual brain cell is either on or off, it means that that rhythm, electrical rhythm at all these different speeds, isn't giving you, as it were, like a movie camera of your world. It's giving you samples of what's happening. So it's like taking snapshots of, for example, the speech signal at all these different speeds at once. So you can think about the way the language lexicon or the dictionary in the child's head is developing in terms of these sound structures as all of these different energy patterns being represented by these brain cell networks. But what you're experiencing as a child is the word garden, word banana. And although we're only talking about auditory processing in this presentation, actually that's happening also with your visual rhythms of speech on the face, and also motor rhythm, because the baby will be trying to copy those sounds and make the same sounds themselves. And so, as I said earlier, these individual differences in how well the baby's brain is able to process these sound structures is what seems to predict individual differences in reading. And that's been found in all languages. So we've got the spoken language lexicon at the behavioral level. We've got this idea of your phonological system, the cognitive system that tells you about sound structures in your language. Then we know that acoustic rhythms are important for the brain being able to learn those phonological systems. And we know that brain rhythms are somehow involved. So a simple way of thinking about this is fireflies. If you think about looking at a dark night when you've got lots of fireflies signaling, they're also like brain cells, just pulsing electricity on, off, on, off. And they're doing it at random. But if you imagine someone standing in that forest and beginning to beat a drum at a particular rate, say twice a second, and that the fireflies then began to signal in time with that drum beat, then you'd have what the brain is effectively doing, a brain rhythm being established. And you can also think about those fireflies choosing to pick up on different rates. So the blue fireflies in that circle might be pulsing in time with the drum beat, but the orange fireflies might decide to pulse twice per drum beat. So they're signaling 2 times faster than the blue fireflies. And again, that's effectively what your brain does. You've got these different networks with their own preferred rates of oscillation, it's called, or their own rates of rhythmic patterning. And they pick up on those matching rates in the speech signal. So what that means is that you're then encoding the speech signal using that matching or that brain alignment. So I've shown the same thing in this slide. You can see all those little blue dots there, the individual brain cells. But if you averaged them, then you would see what's called a local field potential. You'd see this blue rhythmic pattern emerging at that particular rate, which is 10 times a second. And we know that the brain does that at multiple rates simultaneously. And it's also been shown using the adult brain that when somebody starts speaking, so in this slide, we're looking at the brain waves oscillating randomly in the colors before the speech signal begins. The speech signal's there at the bottom in black. As soon as somebody starts talking, there's this rate of change cue that there's suddenly some energy in your environment. And that makes these brain waves automatically align themselves in time with that rhythm pattern. And this is happening completely automatically. Everybody's brain is doing it, and your brain will be doing it with more or less success and accuracy. And so if we try and match that to linguistic analyses of phonology or of the sound structure of speech, we can see that these different levels that linguists have identified. So I'm using an English example here of the bisyllabic word garden, where you have a strong first syllable and a weak second syllable, garden. So that's stressed syllable, then unstressed. And then you can break that down into the individual syllables, like the ga and the dun. Then there's a level that linguists have identified called the onset rhyme level, which simply means you divide any syllable at the vowel. So dun would be d and un. And then, of course, there are the individual speech sounds that we reflect in the English alphabet. So those are called phonemes. But we've also shown in prior work that knowledge of phonemes is largely developed through learning to read. It's those first levels of the stressed syllable and the syllable and the onset rhyme that children seem to have access to before they start learning to read. And these turn out in the speech signal to match these brain rates. So on average, across all human languages, we produce stressed syllables roughly twice a second, which is called 2 hertz, 2 times a second. We produce syllables 4 to 5 times a second. And then this onset rhyme distinction is roughly 20 times a second. So there are 3 different speeds that are automatically there in the speech signal, and they're matched by these brain speeds. So a way of thinking about it is, I don't know if you can see my cursor, but so I've got a nursery rhyme on the first side of the screen, like Mary, Mary, quite contrary. And then I've got the 3 different rhythm rates on the other side of the screen. And we've got the slowest at the top, which is twice a second. And you can see there's a peak, Mary, Mary, quite contrary. So each peak corresponds with a strong syllable and the trough corresponds to the weaker syllable. Then at the 5 times a second or 4 to 5 times a second rate, you've got an individual peak for each syllable, Mary, Mary, quite contrary. And then this faster rate is effectively picking up the onset rhyme distinction for those primary stress syllables. And so it means that there's information in the speech signal itself that can give you this linguistic hierarchy. This is another way of looking at the same thing. So now I've got Jack and Jill at the top of the screen, and the colors that are red and yellow, those are the slower brain rhythm changes, the lower frequencies. The colors that are in blue are higher frequencies or higher pitches. And when you look at the speech signal from this perspective, you can see that those really dominant cues are these slower changes in energy in the speech signal itself at these lower frequencies that match what we've called the so-called stress syllable amplitude modulation pattern and the syllable amplitude modulation pattern. So you've got these particularly large cues for the stress syllables, Jack, Jill, up, hill. And this is all automatically there in speech, particularly when you're using nursery rhymes with children, or in fact, whether you're using baby talk. So a good metaphor is that if your brain is able to be on the beat at each of these different rates simultaneously, then you'll have a very accurate perception of the speech signal, because all your brain rhythms are perfectly synchronized with each other. And if you're talking rhythmically, like using a nursery rhyme or using baby talk, then you're also aligning all those structures in your natural speech. So having heard all that, do you think that dyslexia is visual, or could it actually have its roots in auditory processing? So in the last part of my talk, I'll show you why I think it's actually auditory. It's to do with this speech sound processing system and how effectively it's working in the child's brain, which is something the child themselves cannot control. It's an automatic aspect of perception. So I've tried to show that we have this matching hierarchy. There's the linguistic hierarchy of the stressed syllables and the syllables. There's the brain rhythms hierarchy. And then there's what the child can perceive when we give them a task like, do these words rhyme, or how many syllables in caterpillar. And what you find, again, in language after language, is that children who have a diagnosis of dyslexia have trouble with phonology at every single linguistic level. Although you only normally become aware of this problem when they reach school and they try to learn the alphabet and try to learn to read, so people thought for a long time it must be at the phoneme level. It's actually at every level of the linguistic hierarchy. And in fact, if you're learning a very regular alphabetic language like Italian or Spanish, then children with dyslexia learn letter sound correspondences quite accurately. It's just that they're very, very slow when they're trying to use them. So because the whole speech sound processing system is working slightly less efficiently in children with dyslexia, it slows them down in any kind of task involving speech. How do we know that? Well, we thought of different ways of testing this rhythm problem in dyslexia. So, for example, we used a so-called DD task, where you have famous names for children like Harry Potter, but instead of saying Harry Potter, which would be a strong, weak pattern, you say DD, DD. Or instead of saying Jack and Jill went up the hill, you say D, 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 D. And the child's job is that they hear a couple of these patterns and they have to pick which one goes with Harry Potter. So if they had the picture of Harry Potter and they heard D, 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 the correct answer would be the second one, because the first one was actually the Lion King. And what we've found in many studies is that children with dyslexia are really poor at picking out these patterns, even compared to children who are younger than them who can read the same number of words. So it doesn't seem to be linked to reading experience. It seems to be a fundamental problem in children with dyslexia. And this is just a listening task. But you can show the same thing with tapping tasks. So if children have to tap along in time with a metronome going tick, 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 children who have developmental dyslexia are much more variable in their tapping rates. And that individual variability in being in time with the beat is predicting around 20% of the variance in their spelling, for example. So even though tapping your finger to a beat doesn't seem linked to literacy, it's fundamentally linked through this rhythmic processing system. We also looked at musical rhythms. So I'll see if I can play this for you. We had different chime bar tunes and the children had to decide, are they the same or different? So that was actually an example of a different pattern. But again, what we found was that children who had a diagnosis of dyslexia found it very difficult to distinguish these simple rhythms, whether they were the same or different. Whereas children without dyslexia, even much younger children who could read the same number of words as the older children with dyslexia, didn't have problems with this kind of task. So it really suggests that rhythmic perception is a fundamental problem for children who have dyslexia, both for speech and non-speech rhythm. But of course, for speech rhythm, it suggests that they can't really get to this prosodic structure, what we call speech prosody, or the rhythmic alternation that all languages use to convey meaning. So children with dyslexia seem to have a real problem with this, and it seems to be due to the way their brains are behaving in terms of aligning these oscillating electrical rhythm patterns with those same matching structures in the speech signal. There seems to be a fundamental problem in children with dyslexia in this automatic speech-brain alignment. And we've been interested in this for a long time. So, for example, we have a study of babies who are at risk for developing dyslexia because of family genetics. And this study, which we ran in Sydney, Australia, led by Marina Kalashnikova, we found that you could document differences in babies who were at risk for dyslexia and babies who were not at risk using these kinds of tasks I've been telling you about. So rise time I haven't really talked about, but it's the ability to hear that rhythmic change when the speech signal begins. If you measure that rhythmic ability in babies, even using a non-speech rhythm, the babies who have a family risk for dyslexia were significantly worse at 10 months of age. They also showed delayed language milestones, so things like phonological constancy, which just means recognizing the same word when it's spoken by different people. So, for example, if I say the word rabbit and an old man says the word rabbit, they'll sound physically different. But knowing they're the same word, that's phonological constancy. So that was delayed in these infants. They also had trouble learning new words, at least compared to the other babies. They were much slower to learn new words. And by the time they were 3 years old, we could predict their vocabularies from those individual differences in that rise time parameter, this speech onset trigger cue. That was predicting vocabulary differences at age 3. And by the time they were 4, these children were struggling with that chime bar task I just played you. So there seems to be something conveyed by dyslexia genetics that is making the brain poor at all of these rhythmic type of things. And this is long before they've gone to school and started learning to read. Once you are reading, we can use the same methods we used with the baby rhythm grant to look at older children's brains and see whether their brain responses are on time with these beats of language, these beats in the speech signal. So I'll just give you a couple of examples. This is the children were listening to sentences. They had to repeat back the sentences. We only compared their brain response for sentences they could repeat correctly. But what you can see is that if the sentence of the signal is in the black line, then the blue and the red is showing you the reconstruction using the brain response of that same signal. The children with dyslexia, which are shown in red, are having a much noisier representation of that sentence, even though they've reported it correctly, compared to the children in green, who are the younger children, about 3 years younger, but reading the same number of words as the children with dyslexia, and the children in blue, who were the age-matched controls. So both compared to children who've had as much spoken language experience as the dyslexic children, the blue group, and children who've actually had 3 years less spoken language experience, the green group, we have much more precision in the way the brain is encoding the speech signal compared to the children with developmental dyslexia. The same for those beat-based tasks. So I showed you the ta with the babies. We had the same task for the children with dyslexia. And I've plotted the brain responses in this kind of petal plot, so-called rose plot, because of course the brain is active all the time. So we're just looking at whether the peak activity in the brain is on time with the beat. And the red petals are where the peak activity is for the children without dyslexia, the control children, and the children with dyslexia. And in fact, that was a significantly different peak response. So the brain of the children with dyslexia for a deliberately rhythmic input is out of time. So thinking about that in terms of our metaphor of having to be on the beat, it's as though one of the brain responses, in fact, the one for these stress syllable patterns, the twice a second response, is out of time compared to the rest of the brain. And that is going to mean that your perceptual input is impaired. It's much less accurate and it's more fuzzy than other children. So again, to visualize what that might mean, if we've got somebody singing Jack and Jill to you, which is shown in the black, but your brain is peaking out of time, you've got the maximal brain response when there isn't much speech information, and then you've got a trough or a drop in the brain response when there is a lot of speech information. So it's going to mean that you're perceptually having a different experience to other children. It's a bit less clear-cut, and that means that your speech sound processing system is developing less accurately compared to other children. So what can we do about it? Well, Varun already mentioned some of the quite technical things we're trying, but everybody can do something about this by just doing more rhythmic language with children. So I've circled these slower brain waves, these ones responding at roughly twice a second, this stress syllable rate. Those are the ones that we should be targeting in our early interactions with children who are at risk for reading difficulties, but actually it helps all children if we target this rhythmic language in the early years. So I'll give you one example of a study we did that showed this with children with dyslexia. So I actually got the idea for this study after watching the Olympic Games in 2012, which were in London. And to introduce the games, there was a sort of tour of English history. And to get the Industrial Revolution, the idea had been, we'll have 1,000 people drumming on these steel drums. And I was watching a documentary, and the person who'd had to coordinate these 1,000 people was telling us that he'd only had a day to train them. But it wasn't a problem because he said, if you can say it, you can drum it. And so he told all of them to imagine banging their drumsticks in time with play the drum so your mum can see you on TV. Play the drum so your mum. And he said everybody learned it. There was no problem. They all did it brilliantly. And that made me think that we should do something like that, sort of back to front for children with dyslexia. Because as I've mentioned, they have trouble tapping out these rhythms. But of course, everybody can always learn to improve their performance. So we need interventions with young children that involve music and rhythm making in time with language. So the intervention that we developed in Cambridge, we call it the drumming to say intervention. So we give children these bongo drums. So children like banging on bongo drums. It's an easier rhythm to have than using a drumstick. And then we try and get them to drum along in time with the rhythm patterns in nursery rhymes like Twinkle Twinkle, in poetry. We do music and singing games, because whenever you're singing in time with a musical piece of music, then you are aligning unconsciously your rhythms with the rhythm pattern of an external timer, which in this case would be the music. And you're doing a similar thing if you're playing these playground clapping games and so on, when you're trying to do your clapping with your friend in time with the beats in the language. So any rhythmic experience will help these children, whether it's dancing or marching, but you've always got to be linking it to language rhythms. Just marching by itself or learning to dance won't change the speech sound processing system, but it will be enhanced if you do these rhythmic activities in time with language. And these are things that young children find fun anyway. So it's really showing you the research base for why we should all be using baby talk. We should all be doing as much nursery rhymes and other singing type games and music making as we can with young children, because this is the root of the language system for all of the world's languages. So I'd just like to thank all the people who work in my centre, because these studies with babies and young children, they do require an awful lot of help, but I've deliberately left some time for questions. So if people have questions, now's the time. So thank you very much.
Thank you, Professor. Yeah, if anyone has questions, if you could raise your hands and we take them up one by one.
Thank
So if
you.
you could also share them in chat, then we can get them answered. Yeah, Mohinish, go for it.
Hi, doctor.
Hello.
I think it was one of those sessions which sparked a lot of curiosity within you, right? My question is, so do you think? So you said dyslexic children find it hard to, absorb the rhythmic patterns in the early stages of their life, right?
Yeah.
So can we also make this inference that it's very hard for them to become musicians or perceive those competencies which requires them to become a musician? Because on the contrary, we see that there are a lot of dyslexic musicians, right? And it's like an n number of people there. So
Yeah.
how does it play out in their musical journey if they want to become musician?
So you should never not try and learn something ever in your life, because we can always learn. The brain is very plastic. But when I first started publishing this research, I had a lot of drummers write in and say, this is wrong because I'm a drummer and I'm very good at keeping rhythm. And that's true. There are big individual differences in how musical people are. However, we then did a study at the Royal College of Music in London to try and see whether there were dyslexic students at the Royal College of Music. There are quite a few dyslexic students. And if you talk to them about rhythm making, the real challenge is being in time with other instruments that might have a different so those modulation structures I was talking about, they can either come on very abruptly, like with a drum beat, or they can come on much more gradually, like say you're playing a tune on a violin. Each note that you produce, there'll be a point in time at which our brain thinks we hear that note, but actually the onset of that note will be very extended compared to the drum beat. And so even really high quality musicians with dyslexia who are at the Royal College of Music, that was where they would have trouble in rhythmic timing their instrument with another instrument that might have a different sound quality. So it doesn't mean that you won't be able to be a musician. I've also interacted with dyslexic ballerinas, in London. It was the Ballet Rambert, which is one of the main London companies. So there are huge individual differences in everybody's abilities. These people were still dyslexic, but they could still learn a different rhythm structure, which was their career. So really the message is that the more we do this with everyone, so if those individuals had had special rhythmic focused input with their language when they were younger, they may never have been dyslexic because they obviously had good rhythmic abilities in other areas. It was the acoustic area where the problem was, not the motor.
Thank you so much.
There's another question there.
Oh, yeah. Hello, Dr. Usha. I had a
Hello.
question. You have a lot of studies that are pertaining to early infancy stage, right? I had a question regarding were there any studies or is there enough research to show that exposure to rhythms and music during the prenatal stages also helps in language development in infants and toddlers?
There are some anecdotal studies, but nothing systematic so far. So it's known that during the final 3 months in the womb, you can hear your mother's voice. And people have done studies where, for example, the mother would read a storybook every day for those last 3 months. And then when the baby's born, they get a choice between their mother reading that story or an unfamiliar story. And the babies can show through a sucking response that they prefer the familiar story. So it means there's already vocal learning when you're in the womb. But of course, people aren't normally talking baby talk to you when you're in the womb. It's only once you've come out. But there are other rhythms that you're hearing when you're in the womb, like your mother's heartbeat, for example. So there's a very interesting study now in France where they're looking at preterm infants. Because usually if you're born early, you're put in an incubator in a silent environment. But if you were still in your mother's tummy, you would not be in a silent environment. It would have a lot of rhythm. And so they're trying to play music to these preterm babies to see whether that will eventually enhance their language outcomes compared to other preterm babies who don't get that rhythmic experience. So there are ways of looking at this experimentally, but so far, no one's really looked at whether early music in infancy is predicting language. And again, the baby would have to be doing something active themselves, according to my theoretical work, to really benefit. It's not just hearing music, it's actually linking it to language.
Right. Thank you so much.
Thank you.
Professor, there's a question in the chat by Supriya Iyengar. She says, I guess since speech is inherently rhythmic, instrumental music, particularly percussion, helps. But does instrumental music help more than vocal music?
So according to studies I've done, not necessarily. Although you feel that it's more rich when it's instrumental music. I had a retired music teacher who did a PhD with me, and he was looking at 5-year-olds. And we had 2 types of rhythmic input. Either they did songs that he'd written with his musical accomplishment, or they just had a metronome tapping. And they still got experience with this rhythmic language, but not through singing the melodies to the music he'd written. And actually, those 2 groups of 5-year-olds showed the same progress in their speech and language milestones. So it seems to be the rhythm that's important. It doesn't necessarily have to be rich music, but as long as there's some kind of external beat keeper that you're timing your language to, that seems to be what's really important for progress. So it means that teachers who don't like singing, they shouldn't be scared. They can just chant the words. You don't have to be able to sing in perfect tune in order for these benefits to accrue for the children. You just have to be rhythmic in the way you produce your language. Thank you.
Yeah, I just wanted to add, I think you'd also mentioned that, just reading aloud a story to a child can be very enabling, right? So it's not so much about the musicality, but a rhythm present,
rhythm.
sometimes inherently in certain practices.
I think whenever you're reading a storybook aloud to an audience, you unconsciously become more rhythmic in the way you talk. It's just like when an actor is on stage delivering their lines in a play. They don't talk as though they were just chatting to you on the train. They talk in a special way, and it's actually much more rhythmic. It enhances these energy patterns in speech, even though you're not doing that consciously. That's the effect for the brain of using either baby talk or nursery rhymes or reading a storybook. once you're doing something quite structured, where the language is quite structured, it unconsciously becomes more rhythmic and it exaggerates these cues that the child's brain needs to lock onto. So it facilitates learning.
I also wanted to bring up this point that you make elsewhere, right? That it's very important that a human is singing or a human is telling the story. And it's not like you can play it on television or on your.
Yeah, that is a fundamental point that I didn't do that research myself, but there's been research in America where they so they had English learning babies, but the graduate students were all speaking Mandarin Chinese. And they either interacted in real time with the babies, so handing them toys, showing them picture books, but always talking in Mandarin Chinese, or another group of babies got a film of the same event. So the videos were taken as though the person was interacting with that baby. So someone on the screen basically appearing to hand you a toy. So they heard the exact same language. These babies were very engaged by the screen. They were touching it and they were attending very fully. But the babies who got the live play, they were the ones who learned features of Mandarin Chinese. The babies who just got the video of the exact same interactions, they did not learn any features of Mandarin Chinese. And that those are the kind of studies that suggest that just playing someone on their iPad, a nursery rhyme, is not going to help the brain learn. The brain needs a human being interacting in those early years in order to learn. That's at the foundational stages. It doesn't mean that, teaching remotely isn't useful when you're, say, a student at university, but when you're a young child or a baby, screens do not deliver the same learning experiences as live human beings. There's something about the eye-to-eye contact that seems to be really important in getting the brain online for learning about language.
Shiv Kumar Duraiswamy has a point in the chat. He says, or rather he asks, please highlight the significance of integrating music into the preschool and foundational stages of schooling and its connection to the cognitive domain.
Well, again, it's all about rhythmic synchrony. So if you want to help the cognitive domain of language, then you need to match the rhythmic synchrony of your music or your music making experiences to language patterns, to stressed syllable patterns, effectively kind of enhancing the linguistic hierarchy through the musical hierarchies of beat structures. But it's also important for children in other ways to do music making. So, for example, emotional self-regulation. Things like singing in a choir or being part of a group making music has many emotional benefits that have been shown in other types of studies, like looking at how to counteract depression in adults, for example. But you can show the same thing with children. When you're doing enhanced rhythmic synchrony with other people in your group, it makes you feel better about yourself, it makes you feel better about the other people, and it also helps you with emotional self-regulation. Something called executive function in cognitive psychology, which is basically the child being able to regulate their own feelings about situations they're in, or be able to manage cognitively so that they can decide to listen or decide to remember something. All of those kind of experiences of self-regulation seem to be helped by rhythmic synchronization with other people. So music making will enhance those aspects of cognition, like executive function, as well as language aspects. It's really a very important thing for the preschool and early school years, music making.
Thank you, Professor.
Uh,
Sorry, go on. Lance.
Yeah. So you also talk about rhythm in terms of body rhythm, right? Like tapping and movement that also enables, that's enabling for a child. Could you just throw some light on that?
Well, an example of a study that we've just been running was with a group of collaborators in Spain. And the lady who devised the intervention is actually a preschool teacher, and she had all of the children in her class pretending to be cooks in a restaurant. And so there's cooking terminology that everybody's used to using. You know, if you're trying to play being a grown-up, and in you know, the Spanish words I don't know very well, but you might have English equivalents like casserole or stirring spoon or saucepan. So different syllable patterns in the words you have to use. And in her classroom, the children learned a cooking song. So they were learning about those syllable patterns through singing this song. But then they also had to play with the real things. So like whisking the soup, or I can't remember, but say, you know, kneading the dough, like doing different activities, but so that they were coordinating their muscles, their rhythmic patterns in their hands and their bodies with the rhythmic patterns of the words in the songs. And she got them all doing it together, and it apparently worked. So she was obviously quite a skillful teacher, but some of them would be stirring the soup at one speed, the others would be kneading the dough at a different speed, and then they would swap activities. And it meant that the whole class learning was a rhythmically structured experience around music and language that was great fun, but that also seemed to enhance their reading development as they moved up the school. So we've just written a paper about that and submitted it to a journal, because although we haven't kind of tested it in experimental terms, all the teachers in her school district, they all want to know how to do this, because it seems to help the language and reading skills of these children so much as they move further in education.
Deepika Moglifshetty has a question. What are the habits you recommend parents and preschool educators start developing to take the benefit of these learnings? If you can share your thoughts, would be great. Also, what are the other questions you are exploring now, building on this work?
Yeah. So I think use baby talk. You know, the more baby talk we know that they hear, the better their language milestones. So if you hear more baby talk earlier, you reach your language milestones earlier. If you have parents who sing with you, play games, rhythmic games with you, like nursery rhyme games, or do musical activities with you, even if it's, you don't even need to have a drum, you can just drum on your body, you know, with your hand on your arm or something. But all of these things done together with your parent or with your preschool teacher, they are fun and they enhance language learning for the brain, as long as you match the rhythms to the language. That's really important. Sorry, what was the second part of the question? Oh, what we're doing
What,
now.
yeah, what are you exploring now, building on
So
building on your
I'm
research?
now trying to use this same framework that we developed for reading difficulties to look at children who have really overt language difficulties. So specific language impairment, which is also now called developmental language disorder, where children's production of language is clearly different sounding to other children. So classically, you notice a problem with grammar. So grammar is actually also learned through speech sound structure. And so we've been looking at whether these children get helped by, again, a focus on prosodic structures, on rhythm patterns in speech. And I've got a PhD student who's just finishing this intervention where she would do rhythmic storybooks with these children, you know, Dr. Seuss type books. But the children would be taught to tap with the whole hand if it was a stressed syllable and two fingers if it was an unstressed syllable. So if I use Jack and Jill, it would be like Jack and Jill went up the hill. So there was a very clear mark of whether it was a stressed syllable or an unstressed syllable. And they did that systematically. These were 7, 8-year-olds with these different storybooks. So each time she went to see them for half an hour, they'd go through a new story. They would be tapping out these rhythm structures in the sentences of the stories. Half of the children actually also had to sing them. But what the data show is that you don't need the singing. As long as you're doing the rhythmic tapping, you get these improvements in grammar. So that was, again, very exciting, because usually if you have a speech and language difficulty, you go to a speech therapist who does lots of training about individual speech sounds. but doesn't really do any training about these bigger rhythmic hierarchies in the speech signal. But every language has these hierarchies because we cannot talk at the same level. It sounds very bizarre, like a robot speaking. So the way we convey meaning in all human languages is our voices go up, down, and then we're stressing different levels of prosody all at the same time. And so it seems that if you try and think of an intervention or a learning support mechanism that can help make this concrete for children, like the whole hand versus the 2-finger tap, strong, weak, especially if you're using a rhythmic story, because then in a way the author's done some of the work for you. They've put those rhythm structures in so that they're very memorable, that they have rhymes at the end of each line and so on. All things we know help linguistic memory. But if you also try and make concrete for the children which are the heavy syllables and which are the light syllables, that seems to have this unexpected impact on grammar. Well, it was expected by my theory, but it was unexpected by the larger literature. So what we're trying to do at the moment really is understand overt speech and language difficulties, because I think for dyslexia, we've already really shown what the problem is. It's this speech-brain alignment at this slower rhythmic rate. But for children with developmental language disorder, there's almost no brain imaging studies. We're just starting.
So this, when you mentioned it's only very particularly at a lower frequency, does that mean then when we do any activities with the children related to musicality or rhythm or any of that, and it's related to dyslexia, then it has to be within that particular frequency?
That's actually the frequency that everybody tends to use when
Okay.
you're talking naturally. So
Okay.
if you're deliberately speaking to a rhythm, that's the frequency you try and control. But the thing is that everything's linked together. It's like a kind of cat's cradle. So just by you speaking rhythmically in that way that you can reflect on, which is where are my strong syllables, like Jack and Jill went up the hill, everything else is falling into line as well, because it's all connected. You know, we're making all these different frequencies just using our vocal apparatus. It's all intrinsically connected to each other. So as long as you're speaking properly, as it were, at that fundamental rate, everything else will be in time as well. Yeah, I saw a comment go past on the screen, but it's very hard to read them at the same time.
Yeah, there are a few. So Mohinish has another question. He asks, can a story that incorporates rhythm and musical elements, especially rhythmic repetition, enhance the emotional and sensory experience for adult listeners as well? I asked this because I recently experimented with blending storytelling and music, and it noticeably transformed the way listeners connected with the story.
I think he's right. So I think that there is dementia research showing that people who seem to have lost speech, if you do some musical activity with them, like songs from their childhood and so on, then they suddenly can sing along with you. So they haven't lost speech. Bits of their brain have still got speech. There seems to be something very fundamental about this musicality or rhythmic patterning in speech that's first in, last out. So doing those kind of activities with adults should be very enhancing, especially on the emotional level as well as on the linguistic level, because of course everything's connected. You know, although in research we're trying to just look at one aspect, is it this acoustic thing? It still resonates in your body. Even as you speak, you're feeling what you say. So all of these systems are connected at some level, and doing something that's enjoyable will always have a positive effect on your emotional feelings. And singing is enjoyable, especially singing with other people.
Yeah, that's true. Davina also has a point to share and also a few questions. She says, hi, Professor, this was incredible. Thanks so much for sharing. Quick questions. Have you observed any links between early exposure to lullabies and later experiences with reading or storytelling in childhood? I'm also curious, when it comes to writing for children, How might musicality or rhythmic patterns influence how stories are received or remembered?
Well, before we learned how to write stuff down, it was very important that a local village storyteller knew all the stories and used very rhythmic presentation, which the audience then found helped them remember. So that has been documented many times in research settings as well, that having somebody rhythmically declaiming something makes it more memorable for you. The lullabies, I don't think anyone's received enough funding to look from babies hearing lullabies up till they're 7 or 8 speaking. But it is interesting that if you analyze lullabies across human languages, so somebody in Canada did this, they looked at lullabies in, I don't know how many, but many, many different languages. They all converged on the same beat rate, this 2 hertz rate. It's 120 beats a minute. It's also found in many musical cultures. 120 beats a minute seemed to be the lullaby rate across all these languages that the Canadian researcher looked at. So again, it's coming back to this same rate that we're finding is disturbed in dyslexia. This seems to be something fundamental for the human brain, 120 beats a minute.
Thanks, Professor. Shivkumar also asked if you could refer him to resources related to this subject for further reading.
Yes, he should go on our website because we put all our publications on there. They can be downloaded from there.
Yeah, it's
We've also got a section called Resources for Teachers, I think it's called. And we've got simplified versions of like things you can do with children with dyslexia that you can just download.
nice. We just shared all the links on chat. Elizabeth also shares a cute thank you message which says DDD. I don't know how to say this, but I'm going to try it rhythmically. I'm guessing it's DDDD ga ga goo goo for this super baby talk Gyan. Professor, we thank you.
Okay, thank you.
So thanks for that, Elizabeth. Do we have any other questions? If not, then we will go ahead and end this masterclass. Thank you then. Thank you, Professor, for this lovely, lovely masterclass. And thank you everyone else for all of these questions. We'll see you soon in upcoming masterclasses. Do stay connected with us through our website and our social media pages. And have a lovely evening. Take care. Thank you. Bye-bye.
Bye-bye.
Thanks, Professor Usha.
No problem. You can tell I was nervous because I spoke faster than the 40 minutes.
But it turned out well. We had enough time for questions, so that
Yeah,
was great. Yeah,
Okay.
thank you.
It was lovely.
Thank you very much. Shall I disconnect then?
Yeah, Professor. Thank you.
Thank you so much.
Bye. Bye.
Bye-bye.
रंग चढ़े खुद का ही खुद पे बच्चों को तू ऐसे बढ़ा बचपन मना रे यारा बचपन मना रोशन हो ये नन्हे दिए इन्हें तू रोज सजा बचपन मना रे यारा बचपन मना जादू है ये जीने दे जरा बचपन मना रे यारा बचपन मना गिरने दे बढ़ने दे उनको पास आए तो गले भी लगा बचपन मना रे यारा बचपन मना नई ये दुनिया नया आसमां बच्चों को बचपन से ही सिखा खेलते खेलते साथ निभा ऐसे तो उनका जीवन सजा ये बचपन है त्योहार हर दिन का ये पहचान ले और रोज मना बचपन
तो मना ले यारा।